Okay, let me go to another case, which is case 12. And case 12 is at site 2, 12 feet of gravel, 20 years. We're going to put on the fill for 20 years, then put on the building. We're going to have a basement of 10 feet. Okay, so first thing is that what is the Q? Because now we have a basement of 10 feet. Well, I have to subtract off the weight of the soil removed for the basement. So it's a 10-foot basement, and so 10 times 50 squared is the volume of soil. It's 116 pounds per cubic foot for the gravel, and the building load is 4 million, so 4 million minus the weight of the soil divided by the 50 squared gives us a Q of 440 pounds per square foot. My C sub V for this clay, this is site 2, so there's only the clay, is 15. The HDR, it's single drainage. The thickness is 28 feet, so HDR is 28. And so I get this expression for my capital T. My point of interest is at negative 36 feet elevation. And since I have that 10-foot basement, I have 36 plus 12 minus the 10-foot basement for my Z is 38. So I get 38 for my Z. My B is 50 feet. And so my Z over B is 0.76. So just to make sure you understand where the Z comes from, where the Z, there's my center. This is my distance Z, and you can figure that out. In this case, it's 38 feet. So that means that I have my times now are 20 years here. So I have the 0, the 25, but now this is 20. And then my goal is to get to 25, so this is 0 here, and that's only 5. So using these times, I get these T's. Using this time, I get that T. And using this expression for the T. And then my UXS, well, at T equals 0 plus, for the fill, it's again 12 times 116, 1392. And then what do? I use this T to get that factor. And remember now, it's single drainage, so a T1 of 0.38 with single drainage, what do we have to do? Well, single drainage means what? Then I cross off the bottom part. I'm just using the top part. 0.38 is a line that's, well, it's in here someplace like that, which means the middle is in here. So I'm going to take this point, come down here, so it's someplace between 0.3 and 0.4. So someplace between 0.3 and 0.4 is where our factor. And so 0.36. Okay. So, and similarly, you get a 0.28 for that factor using a capital T of 0.48. Now, for this 5, I get 0.096, which means my factor, same methodology, is 0.77. Now, how do we get this, the 211 here for my UXS2? Well, how do I get that? I have to use my pressure bulb, so that indicates use the pressure bulb. Here's my this is 440 PSF. That's what goes here, because that's the load at the base of the structure, or the foundation base. And then how do I get that 0.48? Well, I get that 0.48, what? I have my Z over B is 0.76, so I use my chart, 0.76, come over here, well, 0.76 is right in here someplace, so between 0.4 and 0.5, and so I got 0.48. That gives me 211 at my, that is 211, that's my t equals 0 plus. And then, like I said, this t gives me 0.77. Then I use the 211, so it's 0.77 times 211 that gives me the UXS2. And U water table, you can all get that. I then sum all of these to get my U. So each, sum all of this to get that U, etc. And then my sigma V, how do I get my sigma V? Well, of course, I use where t equals 0 minus. We look at my t equals 0 minus picture, so you can all figure that out. I look at my picture. Well, that one's t equals 0 minus, so I'm looking at this. There's my point of interest. So I sum that much of dry sand, that much of saturated sand, that much of saturated clay. So that gives me my t equals 0 minus sigma V. And what do I know? Well, these two ought to be the same, right? Because t equals 0 minus, t equals 0 plus. So then, how do I get this sigma V? Well, there are, different ways to do it, but I know my U, I know my sigma V prime, I can add them together, and that gives me my sigma V. That's one way to do it. And then this sigma V and this sigma V are the same, because the picture is the same. In other words, the 0 plus and 20 minus are the same picture. How do we know that? And if I look back at this, there is 0 plus and 20 minus. It's the same picture, so I have the same sigma V. And so these two are the same, and like I say, I've got that, I've got the U, that gives me the sigma V prime by subtraction, and then we use our little trick. Since no time has passed, 0 minus 0 plus, or 20 minus 20 plus, however you want to look at it, those sigma V primes, the primes have got to be the same. And then and then at that stage, I have the 3939, I got the 2334, I add them together, I get my 6273. And then again, this picture is the same as that picture. In other words, 20 plus and 25 are the same, so those sigma V's are going to be the same. Same picture, same sigma V. And so I have this minus that, gives me the 4099. And then I don't need to use that because there's only clay. I come over to here, and remember I have there's my sigma prime I. There's my sigma prime F. The only hard thing to get is the sigma prime P, so I have to think about that for a little bit. And so to get my sigma prime P, I get the original one, which is what? It's my 1.08, which is the given OCR, times the 3048. So there's the 3048. This is my OCR as given. So that comes out to be, so before we did anything at the site, the maximum stress at our point of interest was 3292. But then we put the fill on for 20 years. And so my sigma V prime Z prime I is that. So I now have increased my effective stress. So I take the larger of these two, and that is my, sorry, I compare this one to this one, and I take the biggest one, and that goes there. That's my sigma prime P, the greatest ever felt. So here's my sigma prime I, there's my sigma prime P, so that means what? Oh, they both go here at the inflection point. And the 4099, which comes from here, goes there. That means we're only using what? We're only using that portion of the curve right there. So that means we use only the second half of the expression. And this is my C epsilon C given. And so I just take my expression evaluated, I get 2 zeros 9. My H, the thickness of the clay layer, is 28. I multiply that out, I get 0.252. So 0.09 times 28, that gives me that. And since there's no other layer, I get settlement in the center of the structure of 0.252. And we'll just put the units on it. 0.252 feet. So, oops. .252 feet. Okay, so, and that's all there is for this one. Okay.